In the last section of Chapter 9, we're going to talk about polygons in the coordinate plane. At the bottom of the page, on page 579, you will see key concepts and 3 separate formulas, which you've already done. What I would like you to do is look over that and make sure you understand not only the formula, but when to use it. That's probably the most important thing that you need to take today, is using the formulas you already know, but when to use them in the coordinate plane. So if we turn the page to page 580, problem 1, the got it. Classifying a triangle. So it says triangle DEF has the vertices 0, 0, 1, 4, 5, 2, and it gives the points. Show that this is scalene. So first we're going to graph the points. So I've already drawn the triangle, and we have to prove that this is scalene. So what we need to know is we need to know the distance from D to E, the distance from E to F, and the distance from F to D. And in order to find distance between 2 points, we can either use Pythagorean theorem, or you can use the distance formula. So for example, if you wanted to find DE, right here, DE, here's a triangle, a right triangle. You could do 1 squared plus 4 squared equals C squared and go from there. But we're just going to use the distance formula. So DE, we have the point 0, 0 and the point 1, 4. So that would be the squared root, and I'm going to abbreviate or shorten some steps here. So if I subtract my x's, that'd be 1 minus 0. Subtract my y's, that's 4. That'd be 1 squared, which is 1, plus 4 squared. That would be the square root of 16 plus 1, which is 17. Which gives us approximately a distance of 4 1/10. So now we find the distance of E to F. That would be the point 1, 4 and 5, 2. So I'm going to subtract my x's, 5 minus 1, that gives me 4. 4 squared is 16. Subtract my y's, 2 minus 4 is negative 2. Negative 2 squared is 4. That gives me 16 plus 4 is the square root of 20. And the square root of 20 is approximately 4.5. FD, we follow the same steps. You get the square root of 29, which is approximately 5 4/10. And therefore, we just proved that this triangle is scalene by showing that a scalene triangle, which is this, in this case, has 3 different lengths of measurements. So if you look at practice 1, where it says determine if it's scalene, isosceles, or equilateral, all you have to do is find the distance of each side of the triangle, and then if all sides are the same, it'd be equilateral. If only 2 sides are the same, it'd be isosceles, and if all 3 sides are different, it would be scalene. On the top of page 581, problem 2, classifying a quadrilateral. And then in the got it, it says that parallelogram MNPQ has the vertices, and it gives you 4 vertices. Show that this is a rectangle. So the first thing I'm going to do is graph all 4 of these points. So in order to prove that this is a rectangle, we have 2 things to prove. Number 1, we have to prove that opposite sides have the same length, and we have to prove that each vertice, like for example point N, we have to prove that NP and NM would have slopes that prove that they are perpendicular. So let's do the distance formula 4 times. So let's first find the distance from N to P. N to P we have negative 1, 4, and we have N to P, which is P is 2, 5. So we use our distance formula, subtract our x's, 2 minus negative 1, that's 3. 3 squared is 9. 5 minus 4 is 1. 1 squared is 1. So we take the square root of 10, and the square root of 10 is approximately 3.2. I'm going to do the same steps for the remainder of the sides. So we find out by following the steps for distance formula that all 4 sides are equal. Therefore, we know so far the opposite sides would be equal, so technically it is a rectangle as well. Now we have to determine if all of these sides Like for example, NM and MQ would form a 90-degree angle. We have to prove that all four angles are 90 degrees in order for it to be a rectangle. So we have to use slope. So I'm going to use the red line here. You can use the points and subtract your y's divided by your x's, but I'm just going to count. So for example, I'm going to go from N to P. That means up 1 over 3. Up 1 over 3, so that means that NP has a slope, segment NP has a slope of 1/3. P to Q means down 3 over 1. Down 3 over 1 means PQ has a slope of -3. QM goes from, let's see, up 1 over 3, so segment MQ, up 1 over 3 has a slope of 1/3. And we also know that MN has a slope of -3. Now, the two segments that make the vertex have to be 90 degrees. So these two have to form 90 degrees. These two have to form 90 degrees. So if we look at segment NP and segment PQ, their slopes, 1/3 and -3, are opposite reciprocals of each other. And if you remember, slopes that are opposite reciprocals or have a product of -1 are perpendicular. So these two are perpendicular, these two are perpendicular, these two are perpendicular, as are these two. So we have just proven that this is a rectangle.